Space is vast and dark, but it is also filled with wonders. Among the most fascinating of these are quasars. Quasars are among the brightest objects in the universe. They shine with the light of 1 trillion suns, but they are also incredibly distant. Some are so far away that their light has taken billions of years to reach us. What are quasars? They are active galactic nuclei. This means that they are found at the centers of galaxies. But unlike normal galaxies, quasars are powered by supermassive black holes. These black holes are millions or even billions of times more massive than our sun. As matter falls into a supermassive black hole, it heats up. This creates a swirling disk of gas and dust around the black hole. The disk is called an accretion disk. The accretion disk can reach temperatures of millions of degrees. This makes it incredibly bright. In fact, quasars are so bright that they can outshine entire galaxies. Quasars are not only beautiful, but they are also important. They tell us a lot about the early universe. By studying quasars, we can learn about how galaxies form and evolve. We can also learn about the nature of gravity and the evolution of the universe itself. The formation of a quasar is a dramatic event. It begins with a supermassive black hole. These black holes are found at the centers of most galaxies, including our own. Over time, gas and dust in the galaxy fall towards the black hole. As the material gets closer to the black hole, it speeds up. It also heats up. Eventually, the material forms a swirling disk around the black hole. This disk is called an accretion disk. The accretion disk is incredibly hot and dense. As the material in the accretion disk falls towards the black hole, it releases energy. This energy is released in the form of light, X-rays, and other forms of radiation. This radiation is what makes quasars so bright. The formation of a quasar is not fully understood, but we do know that it is a complex process that involves a lot of energy. By studying quasars, we can learn more about how black holes grow and how galaxies evolve. Quasars are some of the most luminous objects in the universe. They can outshine entire galaxies by a factor of 1,000 or more. But what makes them so bright? The answer lies in the supermassive black holes that power them. As material falls into a black hole, it releases a tremendous amount of energy. This energy is released in the form of radiation, which is what we see as light. The accretion disk around a black hole is incredibly hot. Temperatures can reach millions of degrees. This is because the material in the disk is moving very fast. As the material collides with other material, it heats up. The radiation from a quasar is not just limited to visible light. Quasars also emit X-rays, gamma rays, and radio waves. This radiation can travel for billions of light years across the universe. The luminosity of a quasar is a testament to the power of gravity. As material falls into a black hole, it is compressed and heated to extreme temperatures. This releases an incredible amount of energy, making quasars some of the most luminous objects in the universe. Section 4. A paradigm shift, the discovery and significance of quasars. The discovery of quasars was one of the most important events in the history of astronomy. It revolutionized our understanding of the universe. Before quasars were discovered, astronomers thought that galaxies were the largest and most luminous objects in the universe. The first quasar was discovered in the early 1960s. Astronomers were using radio telescopes to study distant objects. They found a number of objects that were very bright in radio waves but very faint in visible light. At first, astronomers didn't know what to make of these objects. They called them quasi-stellar radio sources, or quasars for short. Eventually, astronomers realized that quasars were incredibly distant objects. They were so far away that their light had taken billions of years to reach us. The discovery of quasars showed that the universe was much larger and more complex than astronomers had thought. It also showed that there were objects in the universe that were much more luminous than anything that had been imagined before. Section 5. Windows to the past. Quasars as cosmic time capsules. Quasars are not only incredibly luminous, but they are also incredibly distant. This makes them valuable tools for studying the early universe. Because the light from quasars has taken billions of years to reach us, we are seeing them as they were billions of years ago. This means that quasars can tell us a lot about what the universe was like in its infancy. For example, quasars can tell us about the rate at which the universe was expanding in the past. They can also tell us about the chemical composition of the early universe. One of the most interesting things that quasars can tell us about is the evolution of galaxies. Quasars are thought to be powered by supermassive black holes at the centers of galaxies. As these black holes grow, they consume gas and dust from their surroundings. This process can have a profound impact on the evolution of the host galaxy. By studying quasars at different distances, astronomers can piece together a picture of how galaxies have evolved over time. This information can help us to understand how our own galaxy, the Milky Way, formed and evolved. Section 6. Unraveling the Universe. Quasars and the study of dark matter and galaxy evolution. Quasars are not only useful for studying the early universe, they can also be used to study the properties of the universe today. For example, quasars can be used to study the distribution of dark matter. Dark matter is a mysterious substance that makes up about 85% of the matter in the universe. It does not interact with light, so we cannot see it directly. However, we can detect its gravitational influence on visible matter. When the light from a distant quasar passes by a massive object such as a galaxy or a cluster of galaxies, it is bent by gravity. This bending of light is called gravitational lensing. By studying how the light from quasars is lensed, astronomers can map the distribution of dark matter in the universe. Quasars can also be used to study the properties of galaxies. For example, astronomers can use quasars to measure the masses of galaxies. They can also use quasars to study the way that galaxies are clustered together in the universe. Section 7. The enduring legacy of quasars. Quasars are some of the most fascinating and enigmatic objects in the universe. They are incredibly luminous, incredibly distant, and incredibly powerful. They have taught us a great deal about the universe, and they continue to be a source of mystery and wonder. The discovery of quasars revolutionized our understanding of the universe. It showed us that the universe was much larger and more complex than we had imagined. It also showed us that there were objects in the universe that were much more luminous than anything that had been seen before. Today, quasars continue to be a valuable tool for astronomers. They are used to study the early universe, the distribution of dark matter, and the properties of galaxies. As we continue to study quasars, we will undoubtedly learn even more about the universe we live in. The study of quasars is a testament to the power of human curiosity. We have come a long way since the first quasar was discovered in the early 1960s, but we still have much to learn about these enigmatic objects.